how you doing?
Great, Stephan, I finally found you.
I'm glad you could make it. What are you looking for?
You! I'm taking off.
What? Mark, you look like a hobo. What's going on here? What are you doing?
We call this field work.
Field work. Well,
This is how you dress.
Where are you going? It's almost the dead of winter.
Now where I'm going, I'm heading off to the Southern Hemisphere.
I forgot you're teaching one of our fabulous off-campus program to Australia and New Zealand.
I am.
Well, I'm almost jealous, but I also realize I get to start off teaching the best course on campus, Bio125. It's all about the information. I'm sure they're going to hear that quite a few times.
You might notice my name is on that course description.
That's true. No.
So,
I'll have them set up for you. We're going to cover molecules of information, and I hope you take it then a little further.
You bet, I'm ready. And I will come with new and exciting information about kangaroos, kiwis, and who knows what all. We will see. But I will be here in this room with this class come midterm time.
And stay in touch. Stay in touch by email, or maybe we'll have some live satellite feeds that you can catch it while you're out there in Australia.
With modern technology, you never know how I will appear in this class.
You just might be appearing. Well,
it could happen.
I wish you all the best, and we look forward to seeing you in a couple weeks.
Keep the class ready.
All right. Do you know your way out of here?
Well, they don't have a ramp, so I guess I'm going the way I came.
All right. Well, take care. Stay in touch. Stay in touch. Right. Bye-bye, Mark.
Good day, mate. We'll be back.
Get out of here. Hello, Zweifel Lab. Mark McCone, how are you doing? How are things going down in Australia with your course? Everybody there? Oh, great. Any problems so far? Too many ice cubes in your lemonade. Oh, I feel for you. I feel for you. Same issues here at Northfield. Yes, started the Bio125 course. Even without you. First lecture was on Monday. I had to cover the basics of the course. I think they are fascinated by the topic of information. I think it's going to be a great structure for the course. And yesterday I covered structure of proteins and the double helix. Yeah, I covered Chargaff's rule. Percentage of A's equals percentage of T's, percentage of C's equals percentage of G's. That's right. That sometimes does cause some questions among the students, and maybe they didn't quite get what we were trying to get there. Well, you know what? There is that fabulous YouTube video from last year's course. Why don't I send that to the class later today? I think I will. All right. Well, if you're just checking in about 125, it's going well. I'm glad to hear things are going in Australia. We'll see you in a couple of weeks back here in Northfield. All right. Take care, Mark. Bye. Now let's see if I can find that YouTube video. So, Raka, how are you doing your 126 class?
My students are fantastic. I love them.
Oh, I think I do too. We're having a wonderful Bio125 class. We're going to have some sort of little competition.
Oh,
at the
hey,
end
Stephan,
of the
Stephan,
Bio125,
I have a burning
126
question
snack.
for you. It's about the structure of DNA.
I got a few minutes, Raka. I'll see you later. We'll talk about the course.
Raka.
Let's come into my office.
All right, this is a big one.
So what was your burning question that you had from reading the textbook there, Mark?
Well, so I'm reading the textbook in detail, like we do, and I'm looking at this phylogeny of bacteria. And right here on the page, it says a whole phylum of bacteria is low GC, and another phylum is high GC. But right in your lecture, you talked about Chargaff's elegant rules about the structure of DNA and how A and G and T and C have to have these exact ratios. How can these organisms have DNA and have different amounts of G and C? Doesn't that break Chargaff's rules?
Well, Mark, I think you misinterpreted Chargaff's rule, and I just so happen to have Chargaff's rule on my whiteboard here and a couple of his data points. But remember from class that Chargaff's rule states that for any given organism, the percentage of A's will equal the percentage of T's, and the percentage of C's will equal the percentage of G's. And these are some actual results that Chargaff did as he broke open the cells and asked the percentage of A's and T's and C's and G's. In a human, for instance, 60% of the nucleotides are A's and T's, 40% are G's and C's. And you'll see it does vary, though. The rat is 56% A's and T's, yeast at 64% A's and T's. So within a human, 30% are A's, 30% are T's, 20% are G's, 20% are C's. It doesn't have to be uniform. And in fact, the fact that it differs between species actually lent some credibility that DNA is genetic information, that there is a bit of difference between different species.
Well, that makes sense. So it could vary, but why would it ever vary? Why would it go between different amounts of G and C or A and T? Is that just random?
Well, there is a bit of randomness in it, yes. But I like the example you brought up, these bacteria. And if you look closely, those high GC content bacteria, those tend to be the thermophiles that you lectured on a little while ago. These heat-loving fellows right here. If you look at their GC content, it's almost sort of off the chart. You know, it can be greater than 60% of the nucleotides are G's and C's. Now, why would an organism have an evolutionary adaptation to have a greater amount of G's and C's? Well, if you also remember from lecture, between A and T, between adenine and thymine, that base pair has 2 hydrogen bonds, whereas a cytosine and a guanine has 3 hydrogen bonds. A considerably stronger non-covalent interaction than the non-covalent interaction between A's and T's. So the theory is the evolutionary adaptation to living in a very hot environment to prevent the DNA from separating is to have a higher GC content than other organisms who aren't faced with that environmental constraint.
That makes total sense. Chargaff is saved.
Chargaff is saved.
Thanks, Stephan.